Okay, in this video we are looking at the algebra of functions, which basically just means a bunch of different ways to combine different functions together. So start off with a quick example here. Say we've got these two functions. Somebody hands them to us. F of x, x squared plus 3x minus 2. G of x is 5x minus 1. And somebody asked me to calculate f plus g of 1. That just means find f of 1, which we know how to do. Replace all the x's with 1 in the function named f. So 1 squared plus 3 times 1 minus 2, which should be 1 plus 3, which is 4, minus 2. I think we get 2. Check that. 1 plus 3 is 4, minus 2 is 2. We find g of 1 using the function g, so 5 times 1 minus 1 would be, what, 5 minus 1 would get 4. So this object here, f plus g of 1, just means f of 1 plus g of 1. So 2 plus 4, we get 6. Pretty straightforward. If we wanted f plus g of 2, we find f of 2, we find g of 2, and then we add them together. F of 2 will be 2 squared plus 3 times 2 minus 2. So what is that? 4 plus 6 minus 2, I think that's 8. G of 2 would be 5 times 2 minus 1, so 10 minus 1 is 9. So f plus g of 2 is just f of 2 plus g of 2. 8 plus 9, 17. Okay, and say we had to keep doing this over and over and over. F plus g of 7, f plus g of 9. There's a shortcut we could take. Instead of calculating each one separately over and over and over, we could just find f plus g of x, which means take f of x, the function itself, not a y value, the actual function, plus g of x, and get a new function. So we'll use the same functions we were just using, f of x and g of x. We'll get x squared plus 3x minus 2, that's the f of x I just had written down, plus g of x, 5x minus 1, and just add them together. Just add like terms, we'll get x squared plus 8x minus 3. So that's this new function we've now created. We have made up a brand new function, f plus g of x. And I could use this to find those things I already found before. I could use this to say, find f plus g of 1. Instead of finding f of 1 and g of 1 independently and adding them together, I can just plug into this new formula and get 1 squared plus 8 times 1 minus 3, which would be 1 plus 8, which is 9, minus 3, 6. The same answer we got doing it the long way. 6. Same thing with 2. I could find f plus g of 2 using this new formula. Instead of doing each one separately, just use the formula that we've just created. We would get 2 squared plus 8 times 2 minus 3, which I think would be 4 plus 16, just 20 minus 3 would be 17. Hey, that's the same thing we got before. Okay. Another example. We don't just add functions together, we can multiply functions, we can subtract, we can divide. Anything we can do with numbers, we can do with functions. We could raise functions to powers. Any kind of algebra we do with numbers or variables, we could do with functions. So if I wanted, using these two functions, m divided by h of 7, well, one way I could do that is find m of 7. Which would be 14 minus 1, 13. Find h of 7, which would be the square root. 7 minus 3 is 4. Square root of 4 is 2. So m divided by h of 7 just means m of 7 divided by h of 7, which would be 13 divided by 2. We're done. Or if I wanted, I could create a brand new function, which is m divided by h. And that would just be m divided by h. So here's a brand new function. Then if I wanted to calculate stuff like this, m divided by h of 7, I could just plug into this formula, or I could do them one piece at a time, either way. So in this case, that was done. Okay. Now if I wanted the domain of this function, what would that be? Well, I would look here at this function and find its domain. That's something people may ask you to do. You may have to do this in homework or on a test. Find the domain of some combination of functions, and you just do the same thing you always do. You're not allowed to divide by 0. You're not allowed to take square roots of negatives. So for this guy, let's do that. Let's find his domain. Okay, can't take a square root of a negative. So the inside of that square root has to be greater than or equal to 0. So x has to be greater than or equal to 3. But you're also not allowed to divide by 0. So the bottom, the entire bottom, is not allowed to be 0. Well, where does this equal 0? Well, square root of 0 is 0. So x minus 3 is not allowed to be 0. We're not allowed to have 0 underneath the radical because it's in the bottom. So x cannot equal 3. So the intersection of these two, I have to have numbers bigger than or equal to 3 so I don't take a square root of a negative, but I'm not actually allowed to use 3 because that would give me 0 in the bottom. So this is not actually true. We actually want x greater than 3, which is the interval 3 to infinity. That's the domain of this combination of functions. Okay, so somebody hands you two functions. You can do any of the stuff you can do with regular numbers. You can add, subtract, multiply, or divide them. F plus g of x just means take f of x, write it down, plus g of x, combine like terms. Same with subtracting, multiplying. You may have to do some distributing, dividing. Just divide top minus bottom, or top over bottom. Pretty straightforward. With numbers, that's about all we can do. With functions, there's this extra operation that now we can do that we couldn't do with numbers, and it's called composition. Composition means somebody hands you two functions. Here's s and q. Let's mix it up instead of using f and g all the time. I've got s and q, and somebody asked me to calculate this thing. S of q of 3. That means, first, do the inside. Always start inside and work your way out. Find q of 3. Q of 3, using our formula for q, will be square root of 4, which is 2. So q of 3, this stuff right here, is really 2. So what I'm really asking for is s of 2. S of 2 is, from the S formula, 2 minus 5, which is negative 3. So composition of functions is you do one function first, get an output. That output becomes your new input for the outside function. Start inside, work your way out. Okay, so say I've got these two functions. I've got g here. Here's g's domain. Here's g's range. G, say, for example, sends 5 over to 2. G of 5 would be 2. Then I've got f. F's domain, the numbers f actually uses, is some subset of g's range. F's domain would be these guys here, 8, 3, and 9. And f sends those over to some guys over here. Composition of functions means I start over here in the domain of g, do g, then take the output from g and do f. So say I wanted, I don't know, f of g of 3. I mean, start over here at 3, do the inside first. G of 3 is 8. So this, g of 3, is better known as 8. I'm really asking for f of 8. F goes from 8, takes 8 to 7. So just following 3 all the way across, boom, boom. So what's the domain of this new function I've created, f of g of x? That question is, which numbers over here in the domain of g go all the way over and have outputs over here? If I tried to do f of g of 12, if I started with 12, I could go one step and then I'm done. I can't finish through. If I tried to do f of g of 19, I don't even have a place to start. 19's not in the domain of g. So the domain of f of g of x are just the numbers that start, have a place to go in g, and have a place to go in f. So following everything all the way back, looks like 1 is good. 1 goes to 3, and then to 2. 3 is good. 3 goes to 8, over to 7. 5's no good. 5 stops, doesn't go all the way through to the range of f. 7's good. 7 goes to 9, through g, and then to 5 through f. 12's no good. Doesn't go all the way through. That's the domain of this new function I've created, f of g of x. Okay, so our notation here, when we're squishing functions together like this, under this new operation we call composition, we will write either f of g of x, where g is sitting inside of f. Sometimes we'll write this little circle here. So we'll read that either f circle g or f compose g. I prefer this notation though, f of g of x. Okay, so like a really nasty example here. Say we've got, here's f of x, here's g of x. I want to write down what I mean by f of g of x. And we're going to do this in a couple of steps here. F of stuff, what I have written here, means rewrite f, rewrite this guy, but instead of writing x, I'm going to write g of x. That's what it means to evaluate a function. F of anything is rewrite f, but instead of writing x's, write whatever is right here. So this would be f of g of x to the 5th plus 7 g of x squared minus twice g of x plus 9. So I've rewritten f, but now instead of writing x's, I'm writing what's in the parentheses here, g of x. But I know what g of x is. I have a formula for that. So this will be, I'm going to need a lot of space here, 3. G of x is all this stuff here. Square root of x minus 8 plus 1 to the 5th plus 7. G of x squared, square root of x minus 8 plus 1 squared minus twice g of x, square root of x minus 8 plus 1 plus 9. And I'm not even going to bother trying to simplify this. That's not the point of this example. The point is to write down some formula, f of g of x, write down the outside function, and instead of writing x, every place you see an x, write down the entire inside function. Okay, how do we find the domain of a composition? Well, we find the domain of the inside function. We find the domain of our final formula. We write down the formula and look at the domain. Any number that's bad in either of those will be bad in the final domain. Okay, so for example, we've got f of x is 3 over x, g of x 2 over x minus 4. Let's write down what f of g of x would be. F of g of x means write down the outside function, f, 3 over stuff. F of x is 3 over your input. What is my input? G of x. So I want 3 over 2 over x minus 4. Okay, this can be simplified. Do a little bit of a keep change flip here. Keep the top. Change the dividing to multiplying. Flip over the bottom. X minus 4 over 2. So I get f of g of x is 3 x minus 4 over 2. I could distribute the 3 if I wanted to, but there's no issue there. It looks perfectly fine the way it is. Now the question is, what is the domain of this new function? Well, if somebody just handed me this, I would say the domain is all real numbers. There's no dividing here, there's no square root, no dividing by x's. There's nothing to worry about. But that's not true. Anybody that was excluded in the inside function still needs to be excluded. Because right here, I would still have an issue. G of x, his domain, x is not allowed to be 4. If we have 4 in g, g of 4 would be undefined. We'd have 0 in the bottom. X is not allowed to be 4. You can't see that in the final formula. Everything looks fine. But just like we had in that picture diagram, if you're not allowed to use it in the beginning, you're not allowed to use it in the end. So the domain here is still x is not allowed to be 4. So our domain in interval notation would be negative infinity to 4 union 4 to infinity. So here's our function. With that restriction, x is not allowed to be 4 because it was excluded from g. And here's the domain of the final function. And you may be wondering, wait a minute, what about f? F has domain restrictions. Yeah, I took care of that by taking care of looking at the domain of the inside and looking at the domain of the final answer. I've taken care of any issues f might have had as well. Okay, that is composition of functions.